13, 14, and 15, we're using the double angle identities. So again, either you'll want my note sheets or you'll want to go on to Alex and go to the dictionary, type in double angle to get your double angle identities. Sine of 2x is 2 sine of x, cosine of x. Cosine of 2x, we had 3 different versions we could use depending on what we want to have in our answers. And then of course we have the tangent one. Normally, again, we'll just use the sine and the cosine ones, but for the cosine, you've got 3 different choices of what you might want to substitute in. So you'll want to keep that in mind. Hopping back over here then. We have the cosine of 2x minus the sine of x, and so we want to substitute in for the cosine of 2x. And so on my cosine of 2x, since this is in terms of sine, I probably want to use the one with 1 minus 2 sine squared of x. So I'm going to use 1 minus 2 sine squared of x minus the sine of x equals 0. Again, I don't like that to be negative, so I'm going to move everything over here. 0 equals 2 sine squared of x minus the sine of x. Nope, plus the sine of x, because I would have to move it over. Minus 1. There. So I have 2 sine squared of x plus the sine of x minus 1. That moved over and made it positive. That moved over and made it positive. That moved over and made it negative. So factoring that, since I have 2 sine squared of x, I would have 2 sine of x times the sine of x. I'm going to have 1 positive and 1 negative. I want this to be positive, so I want my plus and my minus. 1 and 1. That would give me 2 sine of x minus 1 sine of x, which is a positive 1 sine of x in the middle. So either 2 sine of x equals 1, so the sine of x equals 1/2, or sine of x is going to equal minus 1, keeping in mind I moved those over to the other side, so their sign changed. So looking up in my table, again, these are the ones we're going to use with our 2k pi's and all of those. 1/2. So 1/2 is either at pi over 6 or 5 pi over 6. So pi over 6 plus 2k pi, with k being an element of z, or what was the other one I said? 1/2 was also at 5 pi over 6. 5 pi over 6 plus 2k pi, with k being an element of z. Or sine of x equals -1. Sine of x equals -1, we only have one answer there, 3 pi over 2. So 3 pi over 2 plus 2k pi, with k being an element of z. So those are our answers, keeping in mind that we were doing the sign, so that we had 2k pi over there, pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi, or for the -1, 3 pi over 2 plus 2k pi, and of course k being an element of z. So number 14, same kind of thing. If I can get the board moved. We have the cosine of 2x again. Since we have the cosine of 2x, that this is in terms of sine, we probably want to use 1 minus 2 sine squared of x. So 1 minus 2 sine squared of x minus the square root of 3 sine of x equals 1. We're going to go ahead and subtract our 1. Cancels that out. So we have -2 sine squared of x minus the square root of 3 sine of x equals 0. And again, since I want it positive, I'm going to move things over. 0 equals 2 sine squared of x plus the square root of 3 sine of x. So solving that, I'm going to factor out the sine of x. Gives me 2 sine of x plus the square root of 3. So either the sine of x equals 0, or 2 sine of x equals negative square root of 3. Divide that by 2. So sine of x would equal negative square root of 3 over 2. And we're going to find the solutions to those ones. So where does it equal 0? It equals 0 at 0, and at pi, those are the ones we can combine. We don't need the 0 in front. We'd have 0 plus k pi, which is just going to be k pi. So k pi with k being an element of z. Negative square root of 3 over 2 for the sine, we would have at 4 pi over 3 plus my 2k pi, with k being an element of z, or negative square root of 3 over 2 is also at 5 pi over 3 plus my 2k pi, with k being an element of z. So we can oops, not quite that far up. We can combine our first two answers, the 0 and pi, into just k pi, and then we have our 4 pi over 3 plus 2k pi, and 5 pi over 3 plus 2k pi. Oh, put my pen in my hand. Doesn't want to move the board that way. Number 15, this time we have the sine of 2x. The sine of 2x is 2 sine of x cosine of x. So we have square root of 2 cosine of x plus, and we're going to put in 2 sine of x cosine of x equals 0. So looking at that, I can factor out the cosine from both of those. Cosine of x times the square root of 2 plus 2 sine of x equals 0. So either the cosine of x equals 0, or 2 sine of x would equal negative square root of 2, moving that over, divide by 2. So sine of x equals negative square root of 2 over 2. So where does my cosine equal 0? Cosine equals 0 at pi over 2 and at 3 pi over 2. Again, those two are going to be able to be combined because they're 180 degrees or pi apart. So I'm going to have pi over 2 plus k pi, with k being an element of z. So instead of having two separate ones with the 2k pi, we can combine them and just add 180 each time to get to those ones. 4, sine of x equals negative. All right, my card got full, so just going back here to number 15. Cosine of x equals 0. We had pi over 2 or 3 pi over 2. Those were 180 degrees apart, so we could combine those two answers together. Pi over 2 plus k pi, with k being an element of z. When we looked up for the sine of x equals negative square root of 2 over 2, we had two answers, 5 pi over 4 or 7 pi over 4. So these ones are not 180 degrees apart. We're just going to add our normal 2k pi. So 5 pi over 4 plus 2k pi, with k being an element of z, or 7 pi over 4 plus 2k pi, with k being an element of z. So again, for the cosine equals 0, if you look it up, you have pi and 3 pi over 2, which you can combine together into pi over 2 plus just a k pi. And then we had for sine of negative square root of 2 over 2, 5 pi over 4 and 7 pi over 4. Can't combine those, so each of those have plus the 2k pi on the end.